Hey YouTube, welcome back. We're talking about Deca today. Deca is a topic that a lot of people have emailed me and commented about asking for a tutorial. So here we go. For those that are newcomers to the topic, Deca is a A51 security breaker, we'll call it, that runs on GPUs instead of CPUs. And the advantage to using GPUs is GPUs have a lot of tiny cores. My GPU in particular has about 3,500, whereas a typical computer has maybe 8 or 16 cores in its CPU. So instead of having 16 cores crunching numbers, we can actually use GPUs and crunch numbers using 3,500 cores. So yeah, very, very cool project. We've got a lot to cover today, so no long, boring intros today. We'll get stuck into it, shall we? So we're going to be using Deca. Deca requires quite a lot of configuration and setup, particularly on setting up the Kraken hard drive. So that's a whole thing in itself. That's the part that a lot of people get confused with, but your boy Rob's got you covered because I'm going to be walking you through how to set up the actual hard drive as well. So that's, if you scroll down to here, even the author says that, yeah, the setting up of the Kraken hard drive is actually a lot harder than just using Kraken. Kraken is actually a dependency in this tutorial. So yeah, make sure you've got Kraken in your home directory here and make sure you have a Kraken hard drive as well. So I'm using a 2 terabyte Samsung SSD, just a SATA SSD, sorry. So yeah, the GPU I'm using is pretty old now, but still performs very, very well in the modern day. I'm using the classic GTX 1080 Ti, and it's actually a Founders Edition Gigabyte. This is the exact card I'm using. So I've had this card since 2017, and man, it is just a beast. So it's done more cryptography than it's done playing games. So and yeah, what I said about the Kraken hard drive before, if you guys don't know what a Kraken hard drive is, you can go to this video in my Kraken tutorial. And from this timestamp here of 14 minutes and 53, and I'll talk you through how to set up a Kraken hard drive. So go and check that out. And yeah, that's really all the dependencies we need now and the requirements. So I'll just talk about what my software setup now. So I'm using Dragon OS Focal X R37. So a lot of people probably wonder, Rob, why aren't you using Noble yet? Aaron hasn't ported a lot of stuff from Focal X to Noble yet. So my official opinion is everybody should stick on Focal X for now. But still go check out Noble if you want to, definitely. It's a very, very cool project. So, and that's about it, really. I've got a few other things in my home directory here, but we won't talk about them just yet. That's later in the tutorial. So first thing we need to do is we need to install the Nvidia drivers now. And everybody knows that Nvidia is the bane of every Linux user's existence. Your mileage will vary. It may vary, it will vary, right? Typically, proprietary GPU drivers absolutely trash a Linux installation, right? It might not boot, it might crash X. It'll do all kinds of stuff, like maybe it'll make the scaling incorrect. It'll make like these icons and every window like really tiny and everything else is huge. Like it's just an absolute rabbit hole going down the proprietary GPUs on Linux, but we need to do it, unfortunately. So probably don't do this on your main machine. Have a bootable USB or something like that to follow this tutorial is my official recommendation. So first command we need to run, if you haven't opened a terminal window yet, is ubuntu-drivers devices. I've already run that, and we can see that command has picked up that I have a Nvidia GTX 1080 Ti, and it's listed the official drivers for Ubuntu for that GPU. I'm using version 570. When I was preparing for this video over the last few days, I didn't see that actually there's 575. I thought 570 was the latest. So for this tutorial, I'm just using 570 because it worked, okay? When we're talking about Linux, sometimes if something just works, it's best to just leave it be, okay? You don't need the bleeding edge latest and greatest on Linux. If it works, just leave it. Okay, that is a lesson that a lot of newcomers to Linux will learn the hard way. So I'm going to run this command to add the graphics drivers PPA to APT. So I'm just going to run that command. This might take a while. If any of the commands take ages to run, I'll just speed up the video on post-production for you guys. So no stream recording beer today, guys. It's 10:51 on Sunday, so I've got to go and pick my wife up from work. So no morning or afternoon beers for me today. Okay, so that worked fine. So now that we've added the repo to APT, we can actually install the Nvidia driver version 570. So I'm just going to run that command. This will probably take a while. It did last night, but seems to be running a lot faster today. So righto, that seemed to have finished. It was making me a bit scared there for a while. I thought it locked up and froze, but yeah, we're all good, people. So we'll keep rolling with the tutorial. We need to reboot our computer now. So this is the point of the video where I'll probably just pause the recording, and after the reboot's finished and I get set up again, I'll start recording again, and I'll see you guys very shortly. Bye. Okay, guys, I'm back. Couple of minor technical difficulties. I've lost 1600 by 900 resolution after installing the Nvidia driver. So remember what I said about proprietary drivers trashing your Linux? There you go. But yeah, anyway, so I've had to reduce the resolution down to the next 16 by 9 aspect ratio. So yeah, we've lost some screen space, but that's all right. We'll just keep trudging along with the tutorial, shall we? So the next command we need to run after the reboot, and by the way, yep, all the Nvidia drivers worked perfectly as confirmed by running this command here, Nvidia-SMI. So yeah, you can see here that my GTX 1080 Ti is actually running at the moment. So that's pretty cool. Yeah, okay, cool. So that's the drivers out of the way now. Next thing we need to do is install and configure OpenCL. So OpenCL stands for Open Compute Library or something like that. I believe is OpenCL Intel or Apple? Anyway, its main competitor is basically Nvidia CUDA, I think. But yeah, it's basically just computing, but on GPU. So we've got a few dependencies to install. So I'll just clear my terminal here. And we're going to run the pip command to install PyOpenCL. And that seemed to install fine without any issues. The next dependency we're going to install is clinfo. So I'm going to run that command. Okay, guys, I'm back. I appeared to have some internet issues, which I have resolved by rebooting the router, hopefully. So yeah, let's start from the beginning again. Well, not from the very beginning, but let's start from this apt install command here. So I'm going to hit enter on that. Yeah, I don't know. Something's going on. Oh, okay, that's better. Okay, so something was going on when it was fetching the headers. It just seemed to be like really, really slow. So I don't know if that was just a temporary glitch in my internet connection in Australia or not, but it seems to have been resolved now. So we'll continue with the tutorial. So we've just installed an application called clinfo, and that'll show us information about the computer's ability to use OpenCL. So I'll just copy and paste this command here. And I'll hit enter on that. And we can see here it's printed a bunch of information in the terminal window. And yeah, everything seems to be working just fine so far. So that's awesome. So we've got my device name and stuff like that showing up. We've got the driver version here. Yeah, everything seems to be working good, well so far. So that's awesome. All right, we need to... So when you launch one of the, I think it's oclvunkus.py of Deca, it will actually prompt you to ask whether you want to use your GPU or CPU for the task. And so we're just going to add something to our bash RC file that will stop it asking us that, and we'll just default straight to the GPU. So I'm just going to run this command here, and that will just export a Python variable. So when we launch PyOpenCL, it'll just automatically select our GPU and not the CPU. So we'll just confirm that that command runs successfully by using cat to show us that that new entry to the file works. So that's awesome. And what I'll do is I'll just have to quickly open and close the terminal window for OpenCL Vunkus, I believe it's called. Sorry, here's my OCD showing when I'm setting up all my windows. And then I'll just paste that there. So the reason I'm restarting the terminal window, guys, is when we make changes to our bash RC file, we need to restart the terminal window. So that's all done now. So I can minimize all these. Okay, we're getting through the tutorial, guys. Cool. So far we've set up our GPU drivers and we've set up OpenCL on our machine. Okay, so now we're actually going to progress to the part of the tutorial where we're going to acquire and build Deca now. So hopefully my internet issues have been fixed, sorry. So I'll just copy and paste this command here. Just make sure we CD, if you're not already, make sure you CD back into your home directory for this command, guys. Otherwise, it will download the Deca program files to some arbitrary location wherever you are CD'd into. So, and all the technical issues we're experiencing in this video today, it's close enough to midday, so I've went and fetched myself a beer from the fridge. So we'll have video recording beer while we're waiting for this. So Australia is a country the size of a continent, and we have the population of 1.5 Tokyo. So I understand that providing internet communications on this continent is actually really hard, but still, it's no excuse for having poor internet in 2025, even in a country like Australia. So that command to download Deca finished successfully, and we've got it here in our home directory. So we just need to install a dependency, and that is swig version 3. So we're just going to run that command there. Okay, so that finished successfully now. Okay, we're configuring the hard drive now, guys. This is the part that a lot of people get stuck on Deca, I think. But I've devised a workflow which I think you guys will be able to follow along with. I've already got a pre-built delta_config.h, and that is the file that contains the Kraken hard drive configuration. I've already got a pre-made one here, but I'm just going to show you guys quickly a workflow, how you can achieve setting up your Kraken hard drive. I think in maybe about 15 minutes, maybe, you guys should be able to do it once you get your head around how to do it. So we need to open 3 files here. So I'm just going to use the terminal window here to open them up, because I'm lazy. Do everything from the terminal. Okay, so there's a file called Vunkus, I don't know how to speak. I believe Czech is the nationality of the author. So we have this file here called vunkus.conf.py, right? So we're going to put this in the top left-hand corner. And then I'm going to alternate the size. So we have, I think it's, what do we have? 18 numbers here. 18 numbers here and then 2 more. That should be 40 all up, I think. okay? Because it's 40 rainbow tables, right? So we'll just have this file, vunkersconf.py open up here. Now the second window, the second text editor we need is deltaconfig.h. We're going to put this down in the bottom left-hand corner. I'm going to put it right there. And then I might just reduce the size to match the top window. Like this. Now, so this is the tables.conf. This is located inside your Kraken folder, right? And this is when you run the Kraken hard drive building program, it outputs this file called tables.conf, right? So these two files here are in the Deca program files. This one here is in the Kraken program files, okay? So I'm going to put this here so I'm not going to block you guys out with the webcam here. All right, cool. Now, you guys can just open this window completely if you want. So we're going to revert back to, so we'll just leave those three tables there for now, and we'll revert back to our my commands document here. So I'm going to put this up here so you guys can, so it's not obscured by the webcam. So we've got a few things to change here, guys. So when Kraken builds the hard drive, it creates these files called .idx files, and they're located in Kraken indexes, right? So we need to point Deca to the location of these files here, okay? So in my case, the entire path is here. So I'm going to replace this path right here with that. Okay, we need the complete path. Okay, we can't use this thing here, which points to your home directory. We have to use I think they call it a total path, or what is it, absolute path or something like that. So we need to change all 40 of these lines to the location of where your IDX files are. So in my case, they're in home, username, Kraken, indexes, okay? So if you guys followed my Kraken tutorial here, you probably have a similar setup to me, and you will just have to replace the word username with your Linux username, right? And your Linux username is located here before the @ symbol in the host name of the terminal window when you run commands, okay? So there's a quick way to do this. We can go to options. Actually, I think it's find. Is it find? No. We can go to replace. Sorry, Control R. We can get rid of the find, and we can just go Control R or press find. And what we're going to do is we're going to use this tool to replace all of these for us. So we're going to find that text there, and then we are going to replace it with your path. And I'm going to paste that there. And then we can just press down probably 39 times and replace all of those paths like so. Cool, that's done. And just to make sure, if you're doing it manually and not with that tool, we can utilize online tools such as like count number of lines in text tools, online tools. There should be 40 lines, right? Because there's 40 rainbow tables for A51. Okay, so that completed successfully. So make sure you save your progress, because if your computer crashes, you're going to have a bad time, I'm sure. The second thing we need to change, as we scroll down to the bottom of the document in deltaconfig.h, you'll see that we have all these values here. So these values here are if you are using multiple hard drives, okay? Each line corresponds to each rainbow table in this order here. It's a silly order, and even the authors note that it's a stupid order. So, but most people in the modern day, because storage is so cheap and that nowadays, there shouldn't be any excuse for people using multiple hard drives, right? So I'm going to change all these to 0, and it is going to take a long time. So I'll speed up the video while I do that. Okay, I think it's noteworthy to mention too that when we edited all of these values here, make sure there's no comma on the last line there. You see that all these multiple lines have commas. Make sure there's no comma at the last line, and then that also goes for here as well. Make sure there's no comma. And then again, we're going to use just an online tool again to count the lines and make sure there's 40 of them. And there is, so that's awesome. Okay, the third thing we need to do now is specify the disk by ID of where the Kraken drives are located. So here, if you're using multiple drives, you can add, you can list the multiple drives where your rainbow tables are stored. Again, it's 2025. There's no excuse for people to be using multiple drives. So I'm going to actually highlight all of this text here, and I'm going to delete that. So you guys might be wondering now, how do we find the name of our hard drive? Well, that's quite simple actually, because I've got your command right here. And we can just run this command here. And I know for a fact that I'm using a Samsung SSD 870 Evo 2 terabyte here. And I've got the serial number and everything like that. So the line that you guys will need to add is basically copy the entire ID there. And then we go to our delta config H, and then we substitute the text in the default config for our Kraken hard drive. And then we hit save on that. And yeah, that's 3 out of the 4 things. Now the 4th thing I'm leaving till last, because this is going to be the very unfun part. Not enjoyable in the slightest part of the tutorial. Okay. Buckle up, buckos, because you're in for a wild ride here. Okay. The author says this is in a silly order. He is correct. Okay. These here are the offsets on your Kraken hard drive as to where all 40 of the rainbow tables are written in raw format to the hard drive, right? There's no partition table. To Linux, Mac OS, and Windows, this hard drive looks corrupt. It's actually not corrupt. It just has stuff written in raw format to it. And that is where our rainbow tables are. So here's the fun part, guys. You have to cross-reference your tables.conf from Kraken in the indexes folder here. You need to list them all here in the silly order in vankusconf.py, okay? So I'll do a couple for you, and then I'm not going to do anything else because this is a monumental task. You should be able to do it in about 10 to 15 minutes if you are well focused. So this is the workflow that I use, guys, okay? I highlight the number that I'm doing. So this is rainbow table 380. I copy that. I open up the search here. I paste it into there. I search it. And a lot of people might be wondering, why is Rob copying and pasting 3-digit numbers? His brain must be fried and he's got no short-term memory. Well, the reason I'm doing that is because it highlights where I'm up to in the search. So we've got 40 of these to do, right? It might just be easier if you guys remove all of those. And then make sure you put a comma after it. So did you guys see what I did there? I highlighted 380. I found 380 in the Kraken tables.conf file. I got the offset, copied and pasted that there, and then put a comma there. Okay, so I'll go to the next line. I'll highlight 220, copy that. Search for 220 in the text. Okay, I found my 220. I'm going to copy that, put that there, comma, line break. Highlight 100, paste 100 in there, hit enter. Table 100 is stored at 0. Paste the result, comma, line break. I'll do one more for you guys, and then I'm not doing any more because this is just so boring. Highlight 108, copy it. Paste it into the text search. Found my offset. Paste into the document, into delta-config.h, comma, line break. Okay, you guys need to do that 40 times. Okay, and make sure, and it has to be in this order too. You can't just copy and paste this. It has to be in the order of vancusconf.py. Now, I haven't played around with changing the order of this. I probably wouldn't do that because you'll probably have to change the order in like 10 or 20 other files. This is what you have to do, unfortunately, guys, okay? So to save you guys from watching me do this insanely boring task, okay, I can close all these windows now. If I go back to my home directory in the file browser, I actually have delta-config.h that I've built in the past. And I'll just open that up for you guys. And I'm going to copy all of these. This is a pre-made delta-config.h for my specific hard drive, okay? It won't work for your hard drive. It won't work for any other hard drives. This is unique to my hard drive, okay? And then I'm going to save that. So yeah, more or less, I've started that file from scratch in the Deca delta client.h, okay? So what I'm going to do is I'm just going to confirm that I've done everything right by going and just using a, just a text comparing application, right? Online app. So I'm just going to copy my delta-config.h quickly. And then I'm going to copy the one that I built previously. And then compare. Everything. Aha. So I've already stuffed up. Lucky I did this. Yeah, we need the full path, sorry. We need the full path of, oops, what am I doing there? We need the full path in this file, sorry. So that was a stuff up on my behalf. So we need the absolute path there, okay? Cool. So I will highlight that. Clear all. And then I'll just compare. Okay, two texts are identical. Right, all right, we're in business, guys. Okay, so yeah, very important. I actually stuffed up there. So we actually need, so you need your name, get the ID of your Kraken hard drive, and then we need to put dev/disk BioID, and then that put the absolute path there. Okay, cool. Righto, so I don't need that anymore, and my delta-config.h is ready to go. So the reason we have to do the delta-config.h first, before we compile Deca, is because it needs to build all the libraries and stuff on, and delta-config.h is one of the files that you need to do the building process. So we're in business, guys. Let's proceed to the part of the tutorial now where we actually compile Deca now. So we need to cd into the Deca, folder now. So we need to modify the make file, and we need to match the version of Python we've got installed. So Aaron's got Python 3.10 pre-installed in DragonOS FocalX R37. So I'm going to run this command to open up the text editor, and we can edit the make file now. So you'll see here that we have two paths to Python include. So we just need to substitute the text 3.5m for 3.10. And then we hit save on that. I know it's a lot of stuff to do, guys, but I know this tutorial is going to be long. I think we're going to split it up into two parts, I believe. So, all right, cool. So now we're actually going to make Python now that we've edited them. Sorry, we're going to make Deca now that we've edited the make file for our relative Python version. So I'm going to run the make command now. And then that compiled very quickly. That's good. And then the final command we need to run. Okay, so we need to generate the kernel. Okay, and this will create a file called slice.c. Hit enter on that. And then, yeah, if we just go into the Deca program folders now, we should have a bunch of like shared library files, and we should have slice.c there as well. So that's awesome. Everything's working so far. So I'll have a sip of beer. And we'll actually get to the part we're going to use Deca now. So it took us a long time to get here, guys. A lot of technical difficulties and issues. But we're finally here. So I'm going to minimize this window. I'm going to minimize my file manager. And I'm going to open up 3 windows. And a 4th window down here, eventually. So these are the 3 commands here you need to run to start Deca. And there's actually a 4th command as well, the telnet command. So I'll just paste that there. Don't run telnet yet. So we'll proceed to run the 3 commands. So we run papillon.py first. We run OCL Vuncus and just confirm that it is actually using your GPU. And then you'll just have this infinite scrolling thing saying 140 free slots. And then the 3rd command will run as Delta client. And then that's actually loading the rainbow table index file. So that'll just take a moment. So we'll just wait till that's finished. Okay. I think we're in business, guys. So the final command we run is telnet. So with Kraken, right, you just run the binary in the program files. Deca is can only be accessed via a telnet server, which runs on, you could specify the port, but typically the port that everybody uses is quadruple 6. And the IP address is just localhost. And yeah, so let's test Deca, guys. Like, there's not much really more to say. So I've got this text document here, and I'm going to have to open it up for you guys here. Now, a good way to confirm if Deca is actually working is to run cracking commands that address each of the tables. So I've got a list here which will search 38 of the 40 rainbow tables here. I scoured my computer for hours looking for a burst to crack, which would do the last 2 tables. I think it's table 380 and maybe 148 tables. I can't find any bursts for, but this bunch of cracking commands here will search 38 of the 40 rainbow tables. And that's a good way to confirm if Deca is actually working for you guys. So good thing about Deca is we can actually paste heaps and heaps of cracking commands all at once. Not like Kraken where you can only give it one at a time, right? So I'm actually pasting 38 commands right now. And let's see how fast this thing runs on my GTX 1080 Ti. So there's 34 cracking commands that will find 38 results on 38 different rainbow tables here. So let's see if this is going to work. There we go. It's working. Look how fast it's going too. 19 seconds, 20 seconds, 21 seconds, 22, 23 seconds to crack 38 bursts. So there you go. So that's really cool. Let's just crack a single burst and just get the time it takes to just crack a single burst. When I was playing around with this yesterday with the fresh Nvidia driver install, fresh Dragon OS, it was going insanely quick. Like 5.2 seconds quick. So this is a single burst running on GPUs right now. 7.7 seconds. That's all right. It was running faster yesterday, so something must have changed in the setup of what I'm doing. But yeah, 7's about right. I don't know what I changed to make it run at 5 yesterday. Maybe I was playing around with the tuning. That's a whole nother thing, and I'm not getting into that. 5 seconds, 7 seconds should be enough for everybody. I had a viewer email me or comment on my channel saying he had a 4070 Ti or maybe a 4060, and he was getting sub 4 seconds, maybe like 3 seconds and stuff like that. So, yeah, very, very cool. Righto, so yeah, it works. That's awesome. Obviously, you know, you guys can cross-reference these and make sure that all the rainbow tables are getting addressed, and then that's how you know that your delta config.h is configured properly, right? And that seems to be all working. There, I should have 38 results there, but I'm not going to count that. I can't be bothered with that. Okay. So, what are we doing now? Righto. So, we need to talk about the differences in the found result between Kraken and Deca, right? So, you guys can see here that the found result is actually in hexadecimal, okay? If I open up this terminal window here, I've actually run the traditional Kraken, right? And I've searched this same Kraken command here with Kraken, and it's actually displayed the found result in decimal. Okay, that can be a problem for some people, because when you run the find KC command, which this is a typical find KC command, okay? And we found the KC, right? If I substitute, so if I try to put the hexadecimal found value instead of the decimal found value, we will have a problem. So if I put this here, so don't forget, this is the same burst that I cracked, okay? And so this find KC command will be same for both Deca and Kraken, right? So it's not going to work, you see? We've got an issue there. So what you can do is you can just use an online... We can just use like an online hexadecimal to decimal converter. And you can see here that I've just converted essentially the same thing to decimal, right? And you guys will just have to put your own X at the end of that, right? To feed to Kraken, right? You have to put the X there. So once you get your hexadecimal value, you put an X. Okay, that's the naive way of doing it, right? We're super cool hackers, right? So we're going to do something a bit different here. I have a one-liner for you guys. I've got a one-liner here, which will just convert the hexadecimal found result from Deca. You just put that there, put a space after base 16 and the semicolon, and then put the hexadecimal value there, press enter, and then yeah, you've got your find KC command value to put in find KC, right? There's another way to do it, even better way, right? So if we go to my, I'm sorry guys, I know this is very confusing, and I'm trying to be engaging and high energy here, but this stuff just rattles my brain. Okay, I've got to find KC binary that's actually patched to handle hexadecimal and not decimal, right? So I can copy this command here, and you'll see the main difference is here I've got find underscore KC underscore Deca. That's this binary here in my home directory. I can hit enter on that. Whoops, sorry. I should have changed this to that. Sorry about that. And there we go. So that's the patch binary, achieving the exact same thing that the traditional find KC command achieves, okay? So there we go. That's it. That's all I've got. Wow. This whole video is taking almost an hour, so I think I'm definitely going to split this up into a couple of bits for you guys. I think, guys, a couple of parts here. So we'll do a part 1 and a part 2. So yeah, that's it. That's the Deca tutorial, guys. I hope you guys enjoyed that, and I hope it cleared up a lot of things with confusion over Deca and getting drivers to install and things like that. So yeah, I'm pretty happy with how all this went. So I'm not going to delay your guys' afternoon, morning, or evening anymore. So I'm going to say 73, goodbye. That's goodbye and ham radio talk. And hope you guys have had a great weekend. Catch you all later. Bye.